All right, let's dive right in. Today we're going inside the heart of pretty much every single device we use. We're talking about that tiny, unbelievably powerful engine that makes it all possible, the central processing unit. You know it as the CPU.
So have you ever really stopped and wondered what makes your computer actually, well, think? I mean, when you type a sentence, or you're playing a game, or just watching a video, what is really happening inside that machine? How does it turn your clicks into actions on the screen? It all comes down to one incredible component.
And here it is. The source material calls the CPU the soul of a computer system. And honestly, I think that's the perfect way to describe it. It's not just another part, it's the very core, the thing that directs and controls everything, from the hardware inside to the keyboard and mouse you're using.
Now, what's really mind-blowing is the scale we're talking about here. A CPU is basically a microscopic city. And the buildings in this city, they're transistors, millions, even billions of them. They're just tiny electronic switches that are either on or off, letting electricity pass through or blocking it. By flipping these switches in incredibly complex patterns, the CPU does all its magic.
So, how does this so-called brain really do its job? Well, it's not just one thing working alone. It's more like a super efficient team of specialists. And right now, we're going to meet the three most important members of that team.
First up, we've got the control unit. The best way to think about this is as the director of the whole show, or maybe the project manager. Its only job is to go fetch instructions from the computer's memory, figure out what those instructions mean, and then tell the other parts what they need to do next. This is so important, because with one component managing the workflow, the others can just focus on what they do best. It's all about efficiency.
Okay, team member number 2, the Arithmetic Logic Unit, or ALU for short. This is the mathematician of the group, the number cruncher. The ALU handles all the calculations, adding, subtracting, and all the logic, like comparing whether one number is bigger than another. Having this dedicated calculator means all that math happens at lightning speed.
And the third key player is the register set. So if the ALU is the calculator, the registers are its own personal high-speed scratch pad. We're talking about a tiny amount of super fast memory that's physically located right on the CPU chip itself. It holds whatever data the CPU needs to access right now for the task at hand, and its location is everything. If the CPU had to wait for data from the slower main memory every single time, your computer would just grind to a halt.
So here you can see how it all fits together perfectly. You've got the control unit acting as the traffic cop, the ALU doing all the heavy lifting with the math, and the registers holding the necessary info right where it's needed. It's this beautiful, coordinated dance that makes the whole system so incredibly fast.
Okay, so we've met the team. Now let's look at their action plan. How do they actually take a command from a piece of software and turn it into something that happens on your screen?
It all boils down to this fundamental, non-stop process called the execution cycle. You can think of this as the heartbeat of the CPU. It's the step-by-step procedure it uses for every single instruction, millions, sometimes billions of times every single second.
So how's it work? Well, first the control unit fetches an instruction from memory. It's just grabbing the next item on its to-do list. Then it decodes it to figure out what to do. Next, it fetches the operands. That's just the data it needs to work with, like the numbers for a math problem. After that, the instruction gets executed, usually by the ALU. And finally, the result is stored, either in one of those super fast registers or back in the main memory. And then, it starts all over again, billions of times a second.
But what happens when something unexpected comes up? Like you move your mouse, or there's a tiny error in a calculation. The CPU is built for that. It's constantly checking for something called interrupts. These are basically high-priority signals. The CPU can actually pause what it's doing, go deal with the interrupt, and then come right back to its original task without missing a beat.
Okay, we've been way down in the weeds looking at the microscopic details. So let's zoom back out for a second. Why does any of this actually matter to you and me?
This quote really just nails it. The CPU is the one part of the computer that carries out the instructions for everything. Every piece of math, every logical decision, and every interaction with things like your keyboard or your monitor. Without it, a computer is just a useless box of parts.
And that's really the main thing to take away from all this. That complex cycle we just talked about, it's happening right now. As you watch this, it's powering every single thing you see. Every letter that appears on the screen, every frame of video, it's all the end result of this tiny little engine running through its instructions over and over again.
When you stop and think about it, our entire digital world is built on this one simple repeating process.
It's an engine of incredible speed and precision. And that really leaves us with a huge question, doesn't it? This tiny engine already powers our modern world, so what happens when it gets a billion times smarter? What does that future even look like?